Good afternoon, grade 8s. Welcome to the live memo for class test 3A. This is our first class test for term 3. So we need to simplify these products, and we've got some division over here. And looks like we're going to have to use our laws of exponents. So for 1.1.1, we have x multiplied by x to the power 2. So here we have two powers multiplied together, and those powers have the same bases. So we will just apply the law that says that when I have two powers with the same base, I can then add the exponents and keep the base. So I've got x to the power 1. That's a 1 over there. So if we don't see an exponent, it means the exponent is 1. So we've got x, we keep our base, and we say 1 plus 2. And that, of course, will be x to the power of 3. 1.1.2, here we have b to the power 12 divided by b to the power 4. Now, this being a division sum or a division calculation, or the operation that's taking place here is division, we of course have learned that it is usually better to rewrite this as a fraction. So b to the power 12 divided by b to the power 4 is the same as b to the power 12 over b to the power 4. So I would advise and recommend that you rewrite that as a fraction, so that, you know, it's just better to see and better to work with. Of course, this is not really a complex division, and you could have just done it without having, rewritten it as a fraction, but we'll just stick to doing that anyway. So we've got b to the power 12 divided by b to the power 4. So here, of course, we've got in our numerator we have an exponent of 12, and in our denominator an exponent of 4. So we need to, of course, subtract those exponents if we are dividing powers with the same base. So I can keep my base and say 12 minus 4, and that, of course, then will be b to the power of 8. 1.1.3, we have m to the power 3 in brackets raised to another power of 2. So that is a power raised to a power. And if you can recall back to our laws, when we have a power like a to the m raised to another power of n, we can simply multiply the two powers together. So that will be m times n. So applying that to our situation, we've got m to the power 3 to m to the power 3 raised to the power of 2. So that means I can then take m to the power 3 and times it with 2, and I've got m to the power of 6. 1.1.4, here we have a fraction, and in the numerator there is a power of x to the power 3 raised to another power of 2, and in the denominator we have x to the power 3, and this dot here represents multiplication, so that dot is multiplied by x to the power 3. So that is x to the power 2 multiplied by x to the power 3. Now, when we have a fraction, we need to, of course, always look at how can we simplify the numerator, and whether we can in fact simplify the numerator, and can we simplify the denominator, and then afterwards we can divide. So in this case, we've got in the numerator, we've got a power raised to a power. So that means I can say x to the power of 3 times 2. And in the denominator, this is x to the power. Be careful here, because I actually noticed that the mistake made here is that you multiplied the 2 and the 3 again. In fact, this problem was sort of to test your ability to differentiate between a power raised to a power, and here we have two powers that is being multiplied together, where you need to apply the law that says we need to add the exponents. So then applying the law, and that's what we call the product law. So x to the power 2 times x to the power 3 gives me x. I keep the base, and I am going to say 2 plus 3. And then this, of course, will then, if I simplify the numerator, it will be x to the power of 6, and in my denominator it will be x to the power of 5. And once again, at this stage, some of you are still forgetting to divide. So you have simplified the numerator and you have simplified the denominator, but you tend to forget to then still apply the laws of exponents again, which says that if I have two bases or two powers with the same base that's being divided, so a to the power m over a to the power n, I can then keep my base and subtract my exponents. So that's the law you need to apply here, and that means I can then keep my base of x and subtract 6 minus 5 there, and I have x to the power 1, which of course is just x.